All right, I'm gonna get this started. Hello, my name is Britta Dempsey. I'm the coordinator for the Massachusetts Envirothon. Happy to see so many familiar names in the attendee list today, and glad you all could join us after probably a long day of doing regular things. Glad to have some Envirothon in here. The Envirothon is Massachusetts' leading natural resource education program for high school students, emphasizing hands-on, team-oriented problem solving and community involvement that prepares young people for environmental careers and active citizenship. While our 2021 program year is going to be a little bit different, we're so excited to have you all here for our first webinar. Let me tell you a little bit about how it's going to work, and then I'll introduce Kelley. I'm also going to stop the poll in about 20 seconds. So if you haven't voted and you would like to, you should go for it. Kelley would like you to put questions in the chat, and she will answer them as she's going through. And I will be here to poke her if she misses one. Okay. So if you have anything you don't understand or you want to ask for more details on, please put something in the chat. Okay. There, I believe, is also a question and answer function. If it ends up there, I'll relay to her, but she gets a little ding on her screen when a chat comes up. So that's the fastest way to get through to her. We can also take questions at the end, again, written in the chat. Okay. And if there's anything technical, let me know, and you can message me and I'll see what I can do from this side. Okay. So in honor of Imagine a Day Without Water, a World Without Water Day, I'd like to introduce Kelley Freda, who is an environmental analyst with the Massachusetts Department of Conservation and Recreation Water Supply Protection Department. She is also the chair of the Massachusetts Envirothon Steering Committee and has been in charge of the water station since 2011. And she really likes things like the Patriots and rain gardens and making sure that everybody knows not to put any personal care products in the water supply. And you're going to get to hear all about that today. So really quickly, I'm going to end this polling and end the suspense, and then I will hand over the conversation to Kelley. All right. So those of you who said the average person here in the Northeast uses about 114 gallons of water per day. That is a lot more than I thought. Maybe you thought less or more, but that seemed like a lot to me. I didn't realize my showers were that long. And indeed, it is true that the toilets at Gillette Stadium, home of the Patriots, use recycled water for flushing. Not that anybody's there right now, but hey, even the Patriots think recycled water is cool. All right, Kelley, I am stopping sharing and making sure that you are ready. There you go. You should be able to share your screen now.
Hey, we good? Can everybody see that?
I can see it.
Okay.
Your audio isn't awesome though.
Okay, I'll try my best here.
Even that was a little bit better. Thank you.
Okay. All right. So, hi everybody. I am Kelley, as Britta said, and for those of you in the Envirothon that I haven't had a chance to meet yet, I am sorry. This isn't the way any of us wanted this year to start out or to be, but we're going to try our best this year and try to get through it and offer everyone some really cool webinars. Some probably different things that you wouldn't be able to see if we were doing a one-day workshop at UMass. So hopefully you all enjoy it. We've all been putting a lot of work into this stuff, and here we go. So this is going to be an overview of what I usually go through for the first workshop of the year. It's an overview of a whole bunch of different things, some stuff that I find really interesting, and I hope you do too. These first couple of slides are going to be a review, or what I hope is a review by this by the time of high school age. So the water resources of Earth, over 70% of our Earth's surface is covered by water. Although it's seemingly abundant, the real issue is the amount of fresh water available to us. 97.5% of all water on Earth is salt water, leaving only 2.5% as fresh water. Of that 2.5%, nearly 70% of that is frozen in the ice caps, so that leaves us less than 1% of the world's fresh water accessible for direct human uses. And as a tip, as we don't know what the test or the May event is going to look like yet, but I'll tell you now that that is a true or false question on my test, no matter how I will give it. So remember that fact. Less than 1% of the world's fresh water is accessible for direct human uses. Okay, that's the water found in lakes, rivers, reservoirs, and underground sources that are shallow enough to be tapped at an affordable cost. It's regularly renewed by rain and snowfall and is available to us on a sustainable basis. So less than 1% we can use. Okay. Everybody is familiar with the Earth and the globe that we all see that's all blue. If we were going to do a globe showing the amount of water on the Earth, it would look like the diagram on the right, the world's water. The large blue dot is all the water on, in, and above the Earth. The smaller dot just to the right of that is the liquid fresh water, and the tiny, tiny dot that's above Florida is what is available for us to use. So it's really a tiny amount if you're going to compare water of the world. Okay, so surface water. Very simple definition is surface water is the water that is available on the ground surface, the water that we can see. Normally it's a drinkable water source, meaning it's a fresh water. And surface waters include rivers, streams, lakes and ponds, reservoirs, and wetlands. Sometimes it will include oceans, sometimes it won't. Even though it's my favorite subject, we're not going to talk about oceans tonight. We're just going to be talking about fresh water. So sometimes oceans are their own category. Water is made up of 3 atoms, 2 hydrogen, 1 oxygen. Because of the unique chemical property, it's the only natural substance that can be found in all 3 states as a solid, liquid, or gas. A quick review of the water cycle. Continuous movement of water within the Earth and the atmosphere, a system that includes many different processes. Liquid water evaporates into water vapor, which is the gas, condenses to form clouds, and precipitates back to Earth in the form of rain and snow. Of course, when we look further into the water cycle, we know there's a whole bunch of more steps in there. So what is pollution? How does it get there? What can we do about it? Surface water pollution can be grouped into 2 types, what's called point source and non-point source. And they're grouped into these 2 types by the EPA, the Environmental Protection Agency. And they basically did that for regulating. They want to regulate things different ways. So a point source is any contaminant that enters the environment from an easily identifiable and confined place, such as pipes or smokestacks if we are talking about air quality. Okay? So in terms of water quality investigations, if you were to look for a source of a contaminant and you were going upstream, you would be able to trace that contaminant back to one specific point. And it's usually a pipe. If we have any of the Fitchburg team here tonight, you probably have heard about the Nashua River, and this was way before your time and way before my time. But the paper mills that were along the Nashua River used to discharge all their waste directly into the river by pipes, a point source discharge. And a little story that my mother grew up in Pittsburgh along the Nashua River, and she worked in the paper mills. And she remembers when she was younger going to school, and they knew what color the paper mills were using that day by the color of the river. Okay, this was during the late 18th century, early 19th century. So the picture on the left is the Nashua River in the 1960s. The picture on the right is the Nashua River today. It's actually swimmable and fishable today. And that's because of the laws that the EPA put into effect to monitor what's coming out of any pipes. No longer can you just dump anything down your drains and dump it into the rivers and streams. And I think Britta is going to try to put up another poll question. I'll give you a second to answer that. Okay, Britta, are we good?
Kelley, can you see those poll results
Yes.
on your screen?
Yes, I can. Thank you. Okay, so a majority said agriculture and industrial pollution. Okay. I'm glad we have Britta as my technology person because my screen's stuck now. There we go. Thank you. Okay, so while all four of those were contaminants in their own right, the most significant source of water pollution to surface waters is from stormwater runoff, which is a non-point source pollution. When you hear non-point source pollution, want you to think preventable personal pollution. These are the things that we leave on the ground every day. The automobile leaks that we leave in parking lots at the mall, the trash that we throw on the ground, the dog waste, the wildlife waste. Non-point pollution is harder to identify than point source, and it's harder to address. Pollution that comes from many different places all at one time. So it's like a big mixture of pollutants and contaminants coming from everywhere at the same time when it rains. Some non-point sources, urban streets, the more pavement and impermeable places that we have, rooftops, all of that runoff is a potential non-point source of pollution. Okay, everything we leave on our streets. Suburban development, again, impervious surfaces. Rural homes, think of the things around your yard. If you have bare spots in your front lawn, when it rains, that's probably running off into the street. Unmanaged croplands and agriculture is a source of non-point source pollution. Okay. And at the bottom of this diagram, you can see point sources. Wastewater treatment plants are a point source pollution. Point source. Okay. So manure from agriculture would also be a non-point source pollutant. Okay, so dog waste. I could keep you here all night talking about dog waste, but I'm not going to do that. I'm just going to give you a quick overview. Dog waste is a huge problem. It's a huge contaminant in water supplies, not surface waters. It contains bacteria and parasites. It also contains organic matter and nutrients such as nitrogen and phosphorus. In addition to diseases, the organic matter and nutrients break down in the water. Once that happens, it uses up dissolved oxygen and it sometimes releases ammonia. Combination of low oxygen, increased ammonia, and warm waters can kill fish. And these are usually the fish that are sport fish. People are out fishing in recreation for. Excess nutrients can lead to cloudy green water from accelerated algae and weed growth. A couple things you probably never wanted to know about dog waste. It's estimated that an average dog produces 3/4 pound of waste per day. In 1 gram, about the weight of a paperclip, contains 23 million fecal coliform bacteria, which is almost twice as much as human waste. Cats aren't innocent. They usually bury their waste. If you ever watch them in a litter box or outside, they're burying it. So it's not as likely to run off from the surface as dog waste. Another type of pollution is called thermal pollution. It's a degradation of water quality by any process that changes water temperature. Okay. Think of walking over hot pavement on a summer day at noontime when the sun's shining right overhead and you're barefoot. Your feet are going to burn. That asphalt heats up really, really fast. And what happens is it will rain, and that rain immediately heats up. It either runs directly into our surface waters or it will go into a storm drain, which acts as an underground river, basically, and will discharge into the surface waters. I like to use the analogy that it's like pouring hot water in your home aquarium. It's going to change your water really fast, and your fish aren't going to be really happy. What's important to note is that I usually equate thermal with heat, but it can also work the other way. Industrial sites, they can discharge cool water and change a warm water to a cooler water, and the fish, again, go into shock. So it's anything that changes the temperature of that surface water is considered thermal pollution. Just as an idea, when the air temperature is 77 degrees, the asphalt temperature can be 125 degrees, 86 degrees, asphalt is 135, and at 87 degrees, it's 143 degrees. So if you think of that cool water and how fast that heats up and how fast it's going to heat up the surface water downstream. Some simple things we can do to help the water quality of our surface waters. Can wash your car on the lawn or take it to a car wash. Contrary to popular belief, soap isn't going to kill your lawn. Can sweep sand away from a road and storm drains. Never fertilize the lawn before a heavy rain. Make sure construction sites are managed properly. Throw unused medications out properly, crushed and in the trash, or if you have a medicine take-back day or a medicine drop-off box. Fix car leaks. One car leak isn't a bad thing, but when next time you go to a grocery store or the mall and you're walking into the store, see how many automobile stains are in that parking lot and what's going to happen to all that the next time it rains. Picking up after your pet, that's a real important one. Never ever dump anything down a storm drain. Storm drains are for rain and clean rain only. Just dispose of hazardous materials at a collection event. Don't throw your trash out the car window or the ground. Limit any use of pesticides, insecticides, or herbicides. And don't feed or attract wildlife. So some current water issues. Prescriptions and medications, pharmaceuticals. This was a big issue a few years ago. We don't hear about it as much now, but it is still a problem. So in 2008, the Associated Press released an extensive 5-month study on drinking water supplies. And what they found, that there was a whole bunch of pharmaceuticals found in drinking water supplies of at least 41 million Americans. Also found that the problem isn't confined to just surface waters. They also get into aquifers underground and groundwater, the source of 40% of the nation's water supply. In most cases, the chemicals are found in concentrations in the range from less than 1 part per billion to 1 part per trillion. Now, those are tiny, tiny, tiny numbers in the scheme of things. It's like 1 tennis ball out of 1 billion tennis balls, or 1 golf ball to 1 trillion golf balls. They're extremely minute numbers. And what's happening is that as equipment is getting better at detecting these chemicals, they're finding more in waters. Not much is known about the health risks to humans yet. They're still doing studies on it. The only thing I'm going to say about this slide is that some of the pharmaceuticals they have found are turning the male fish into female fish, and it's affecting the amount of baby fish that we have. So how is this working? We're given a prescription from a doctor, or we take medicine for a headache. The first way it's entering our water supplies, which is used to be the way that they told you to get rid of these things, if you had expired or unused medications, they told you to flush it down the toilet. From there, it went either into a septic system or a sewage system. And if you're not sure if you have a septic system or if you are part of a public sewer system, that's your homework. You should find that out first. So it goes into the septic system, it discharges through what's called the leach field, and it goes back into the groundwater. Now, a leach field is supposed to clean out anything that isn't clean water. What's happening with the chemicals today in pharmaceuticals is that there are new chemicals every day, and these systems, septic systems and public sewer systems, were not designed to get rid of all of these chemicals. The next time you're watching a half-hour show on TV, count how many commercials are on showing you new and improved medications. It's very, very interesting how many you're going to find. And those are all new. So as new things are coming out, these systems were not designed to remove them. So what's happening is these chemicals are going through a leach field where they're not supposed to be, getting into the groundwater, and the groundwater eventually goes back to surface water. And if that surface water happens to be used as a drinking water supply, it's coming out of your water tap, and it's coming back to us. If it's going to a public sewer system, your water does go to a water sewage treatment plant. Again, because these were designed so long ago, they are not removing all the chemicals. And they are doing studies on how to make these more efficient, but they're not there yet. And again, the same thing. Clean water from a sewage treatment plant is discharged directly back to a surface water downstream. And if that surface water is the drinking water, it's coming back. The same kind of circle happens if you're excreting it, because all of these chemicals don't stay in our bodies. So anytime the toilet is flushed, you're getting these pharmaceuticals going back into the water supply. Okay, so now we're going to add in other shower and beauty items, such as shampoo, toothpaste, anything we might use on our bodies, soap, exfoliators. And we can even go further and have perfumes and suntan lotion and bug spray. When these are combined with pharmaceuticals, it's called pharmaceutical and personal care products, or PPCPs for short. Okay. So that is what's called an emergent contaminant. Okay. What I found really interesting is that during all these studies, what they've found mostly in our water supplies are antibacterial products. It's the biggest offender. The other two of the top three are caffeine and nicotine. So now we're going to talk about plastics a little bit. Microbead Free Waters Act of 2015. This act was put into place to phase out manufacturing of face wash, toothpaste, and shampoo containing plastic microbeads by July 1st, 2017, and the sale of such beauty products by July 1st, 2018. Plastic microbeads designed to be washed down the drain and too small to be reliably captured by wastewater treatment facilities pollute lakes, rivers, and oceans. One tube of exfoliating face wash can contain more than 350,000 microbeads, and it's estimated that 2.9 trillion microbeads enter U.S. waterways annually. And you can see in the bottom picture how tiny these little plastic pellets are that were found in everyday care products. Now these are banned, so the companies are actually looking towards natural ways to make exfoliants and toothpaste and those kinds of things. They're looking at using almond shells. Procter & Gamble, I think, was one of the first ones to switch from plastic to natural sources. What happens when these little microbeads get into our water supplies? And they found it more in oceans than in fresh water so far. What happens in oceans is that these fish eat the microbeads. And who eats the fish? We do. So it's an important thing to keep plastics out of our water, whether they're microbeads or regular plastics, because plastics break down. And then you get tiny plastic, and then you get chemicals. So it's important that we keep all plastics out of water, whether it's our fresh waters or our oceans. Okay, so we're going to talk about drought a little bit. So we just turn on our tap, we'll always have water. That's the thought. We don't have enough water, is it really a big deal? Half of the world's population now lives in countries with declining water tables. So a drought is shortage of rainfall, and we've all heard that the past couple weeks. Massachusetts isn't in the greatest shape with our drought this year. Some impacts of not having enough rain is losses or destruction of fish and wildlife habitat, lack of food and drinking water for wild animals, increase in disease in wild animals because of reduced food and water supplies. There's increased stress on endangered species, lower water levels in reservoir lakes and ponds, drinking water supplies and wells going dry. There's a loss of wetlands, can be more fires, wind and water erosion of soils and reduced soil quality. And it's changes in water quality happen when there's not enough rain. Waters become warmer, increases in bacteria can happen. And this is our drought status as of last month. I know it seems like it rained for the past week, but we're still in a drought this year. So other things, when there's not enough water, it's not just drought. There can be fights over water. And these are just some newspaper articles from the past 10 years or so. Great Lakes states prepare for water wars. Fight brewing in Nevada over water rights. Fight over water rights brewing on Maui. Georgia battles U.S. government over water. Closer to central Massachusetts, water fight already rages over Wiki-Piki. This was at a time where Nestle Waters wanted to tap into the aquifer. Store shelves stripped, some fight for water, stores closed, residents stock up on water. That was a headline from 2010 when one of the main pipes going to Boston burst and there was no water going to Boston. People got into fights in stores. They had to close stores, no bottled water. So when there's not enough water, whether it's drought or other means, it's never a good thing. And something that I find really interesting is that sometimes people aren't fighting other people for water, but people are fighting nature. There are some plants called phreatophytes. They have long root systems that are fighting wells in more arid areas. So they're trying to steal underground water from people who are also trying to get the underground water. Some of these plants can have roots up to 85 feet deep. And tamarisk, or salt cedar, it's a type of phreatophyte. It's an invasive non-native plant, but it can cause severe problems because it robs rivers and aquifers of waters, particularly in the southwest U.S., the desert areas. So in January 2014, a study that was in Nature Climate Change found that droughts will probably set in more quickly and become more intense as climate change takes hold. We've seen this the past few years. In 2014, 90% of California was suffering from severe or extreme drought. Besides people in California, there was nearly 1 million acres of farmland. That's when our bananas start to cost us $4 a banana, and tomatoes cost $6 when there's not enough agriculture to supply the people. So water is important all around. So that brings us to what today is. Today's Imagine a Day Without Water. Imagine if there was no water in our tap during this pandemic to wash our hands, when we're told 100 times a day, wash your hands, wash your hands, wash your hands. That should tell us how important water is to us in our daily lives. Besides our health this year, we would have no water to drink. We'd have no coffee, soda, or sports drinks. There'd be no swimming pools, no water to shower, flush the toilet, or do laundry. Hospitals would close, and firefighters couldn't put out fires, and farmers couldn't water their crops. Disease would spread. Okay, this year, imagine if in the western part of the U.S. and in Colorado, firefighters didn't have any water to put out the fires that are going on now. And I guess what I really want you to do is to think if you can go a day without any water. So it's a day to appreciate water and make a pledge to protect it. Okay, so drought. Now, is this such thing as too much water? We're going to talk about flooding. Floods disrupt normal drainage systems in cities and typically overwhelm sewer systems. Thus, raw or partially raw sewage spills are common in flooded areas. Additionally, if the flood is severe enough, destruction of buildings that can contain a large array of toxic materials, paints, pesticides, gasoline, can cause the release of these materials into the local environment. If you think about what you might store in your garage, I know I have gas cans for my lawnmower and snowblower. I have some paint cans. If we think nationwide, or even New England, or even take your city, if we had a flood big enough to get into your garage, all of that would be flowing all over the place. So in some older cities and towns, they have what's called a combined sewer system. So they use the same set of pipes as storm drains for their wastewater. What I want you to remember in some of these older cities, when they show on the news flooding and people are walking around with their jeans rolled up to their knees, walking through flood water, or out playing in it, or in a kayak, most likely they're walking through a mixture of sewage, rainwater, and any other toxic material that might be out there that's flooded. And these pictures are from Hoboken, New Jersey after Superstorm Sandy. So when we have flooding, what results is a high number of mosquitoes. Because mosquitoes breed and live in excess water, they carry diseases that afflict humans. They can also transmit diseases and parasites that dogs and horses get. These include dog heartworm, West Nile virus, and Eastern equine encephalitis. So we don't want standing water. And when we have flooding, we're going to have standing water. And also a few years ago, the Zika virus was a new one. These are headlines after Hurricane Florence in North Carolina. Wasp-sized mosquitoes that bite through clothing are swarming North Carolina after Florence. Giant mosquitoes emerge in North Carolina. Mega mosquitoes. Mosquito apocalypse. North Carolina swarmed by monster mosquitoes. I don't know about you, but I don't want to see these things. I'm not a big fan of flying, biting things. So these are things that we never heard before. And that's from flooding. Flooding decreases the effectiveness of water treatment for a drinking water supply. After any flooding event, more treatment is usually needed to make that water safe for you to drink. So the more treatment that's needed, when you start to pay water rates, you're paying more money because of flooding to make sure that your water is safe to drink. And these photos are very, very telling. The top picture is the North Carolina coastline on a normal day. The bottom picture is the North Carolina coastline after flooding in a large storm. And what happens is agricultural sites, and North Carolina has a huge agricultural area, over 2,200 pig areas and more than 3,900 poultry areas. What happened is all the runoff contained manure. And you can see it in the tributaries that are going right into the ocean. And that's the ocean, and those dark spots are all manure and pollution. So just an example of how it's very important to take into effect what the climate is, where we locate agriculture and other potential pollution sources. With climate change, it's even more important than ever. This is also pollution after Hurricane Laura in 2020. This is the Louisiana coast, and you can see all the oil in there. And that was due mostly because there were a lot of oil wells that weren't being used any longer that flooded. So climate change and global warming, what does it mean for our surface waters? Although we use the terms and hear the terms interchangeably, we hear global warming, we hear climate change. By definition, they mean two very separate things. Global warming is an overall warming of the planet based on average temperature over the entire surface. So the entire Earth temperature raising. Climate change is changes in regional climate characteristics, including temperature, humidity, rainfall, wind, and severe weather events. So this is regionally. Scientists predict that climate change will result in stronger, shorter, more frequent precipitation events. We're seeing this already. Climate has been linked to infectious diseases, and the use of climate information has been recommended for early warning systems for epidemics. Imagine if this pandemic was in the water supply. And I'm not going to say much more about that, but it is a total possibility with climate change. So there's a growing evidence that weather is often a factor in waterborne disease outbreaks. With expected increases in precipitation in the northeastern United States from climate change, there's a possibility that there will be alterations in risk of waterborne illnesses associated with heavy precipitation. Actually, I'm going to say a little bit more about this. Infectious diseases and waterborne illnesses are usually gastrointestinal. So the fact that during this pandemic, we couldn't buy toilet paper, imagine if everybody had a stomach ache and was using the bathroom 50 times a day. Imagine the disaster that would have ensued if that was the case. And it's a total possibility with climate change. So blooms like it hot. Changes in temperature and rainfall are expected to lead to an increase in cyanobacteria, sometimes called blue-green algae blooms. Cyanobacteria and algae blooms are a direct result of nutrients, in excess of nutrients in our surface waters, nitrogen and phosphorus. Both of those are found in human waste, dog waste, fertilizers. It's plant food. It's like putting fertilizer into our surface waters and making weeds and algae grow. Harmful algal blooms increase turbidity, smother aquatic plants, and take away invertebrate and fish habitats. When the algae dies off, the bloom takes out all the oxygen and it can kill the fish. So sometimes during a hot summer, you'll hear of a fish kill. And more than likely, the cause of that is an algae or bacteria bloom. And sometimes the cyanobacteria can produce toxins, which can cause serious and occasionally fatal human liver, digestive, neurological, and skin diseases. And most toxic algae blooms are horrible for dogs, cattle, and wildlife. That's when you see signs saying to keep your pet away, not drink it or go into it. Okay, this is a picture from 2014. It's a toxic algae bloom. Resulted in 500,000 people unable to use their tap water in Toledo, Ohio. And you can see on the satellite photo on the top, that bright green is that algae bloom. And closer to home, toxic algae shut down Brewster's Cliff Pond. This is a few years ago. Shrewsbury warns that Dean Park Pond has toxic algae. This again was a few years ago, but it happens every year. And it's going to happen more and more and more because the intense rainfall events that we're having is washing more of these nutrients into the surface waters. What happens then is there's way more than that water needs or can hold. And as it's plant food, all this stuff grows and grows and grows. And we're going to find this more often as climate change happens. So back in 2008, we had ice storms. It wasn't really cold enough to produce snow, and it wasn't really warm enough for rain, kind of in the middle there. 2011, we had a tornado in Brimfield. We don't have tornadoes in Massachusetts. They happen in Kansas, in central part of the United States. We had a tornado in Massachusetts. Then in August 2011, we had Tropical Storm Irene, dumped 11 inches of rain in some parts of Vermont. It was the 7th costliest hurricane in U.S. history, and that was inland. Then we had a Halloween blizzard in 2011. Lack of snow the rest of the winter. Then we had a drought in summer of 2012. We had Hurricane Sandy, called the Frankenstorm, October 2012. If you watch the news the week before, it was a monster storm, a mega storm, an unprecedented storm, humongous, catastrophic, mammoth, superstorm, epic. These words I never heard when I was younger about a storm in this area, ever. We're hearing it more and more and more every year. Then we had Winter Storm Nemo, dumped 20 inches of snow, wind, and coastal flooding in February of 2013. Then a month later, there was Winter Storm Saturn, which finally took down houses on Plum Island that were hanging on for a long time. Then there were weeks of extreme heat waves in that summer. There were tornado watches and warnings that had become the new normal. Every afternoon we'd hear tornado watch or warning or a potential. There was torrential rain, severe thunderstorms. There were fish die-offs because it was so hot. And this was in central Massachusetts. Typhoon, November 2013, Philippines destruction. It was the strongest storm to ever make landfall. Tornado outbreak brings late fall terror to the Midwest. Then we had a tornado in Boston. We don't have tornadoes in Revere. We don't have tornadoes in Central Mass, but we do. Records broken of snow in 2015. Snowzilla in 2016, there were feet of snow in Washington, D.C. Washington, D.C. isn't equipped to get rid of the snow that falls in Washington, D.C., so they were shut down for weeks. Another tornado in 2018 in Webster, Mass. Then Hurricane Florence in 2018, where headlines where meteorologists are running out of adjectives to tell you how bad Hurricane Florence is going to be. Florence, Helene, Isaac, and Joyce, all hurricanes in the Atlantic in 2018. The first year in 10 years that the Atlantic hurricane system produced 4 named storms at the same time. October 2018, unprecedented event unfolding in Florida. Catastrophe nears, water levels rising, winds increasing. September 2020, the second time on record the Atlantic has 5+ tropical cyclones simultaneously. Again in September, historic wildfires raging on the West Coast. In just 2 weeks ago, these were the headlines. And it's not happening just in the United States, it's worldwide. In 2013, there was droughts, wildfires, and temperatures up to 130 degrees in Australia. And 2 weeks later, they had severe flooding from record rainfall. Okay, and some of Australia's headlines: thunder snow, dust storms, and gale force winds. What's going on with Australia's weather? What I'm trying to tell you, and I could have made those slides a lot longer, is that our weather is changing. And I'm not here to tell you political side, non-political side, but as scientists, we need to look at the science. And if nothing else, those slides should give you the idea that our weather is changing. And these storms are bigger and they're different, and our weather is different. So if it's not climate change changing it, something else is. So as part of your research, you should be looking at climate change and what's going to be happening. So as far as fresh water, if global warming continues to melt the glaciers in the polar regions as it is, the supply of fresh water is going to decrease. And remember, we said that 1% of our water was available. So the first way that's going to happen is fresh water from the melting glaciers will mingle with salt water in the oceans. It's going to be too salty for us to drink. Second, the increased ocean volume will cause sea levels to rise, contaminating freshwater sources along coastal regions with seawater. Okay? As that water table changes along our coastline, that salt water is going to be able to get in there, and it's going to contaminate the fresh water. This is a picture of a glacier in Alaska. The front of the glacier moved back about 7 miles, and the thickness decreased by more than 5,625 feet. So as that ice is melting, what's happening? The sea levels are rising, and the fresh water is mixing with the salt water. So in a 2009 Nature study, and an also 2012 journal Science study. This is what Harvard Yard would look like with a 25-foot sea rise. You could see that would be totally underwater. So more frequent and heavier storms, of course, it's going to change water quality. So the characteristics of the Northeast United States: large, mostly urban population, generally adequate water supplies, large number of small dams, but limited total reservoir capacity, heavily populated floodplains. That means that a lot of people live in flood areas. So decreased snow cover and amount of duration, possible large reductions in stream flow, that we're already seeing, accelerated coastal erosion, saltwater intrusion into freshwater aquifers along the coast, changes in magnitude timing of ice freeze breakup with impacts on spring flooding. That's a very important one for drinking water supplies that use a surface water reservoir. Drinking water suppliers count on the ice cover in the winter to protect water quality. When you don't have that, water quality is affected, and it's going to cost more money to treat. The shifts in fish species distributions and migration patterns. And I'm not going to read this slide because these are all available on the Envirothon website. You could read for yourself. This is from 2014 in the EPA's climate change indicators in the United States. That's also been updated in 2018. The facts are the same, nothing's changed, but you can read that on your own. A little bit about aquatic invasive species, what's commonly known as AIS. These are introduced plants that have adapted to living in, on, or next to water, and that can grow either submerged or partially submerged in water. They have the potential to establish and spread very fast due to lack of physical and biological constraints in the habitats to which they have been introduced. So once one plant gets into a water source, they spread very fast, and they can cost a whole lot of money to try to get rid of them. The range of impacts that invasive species can have on the systems is extensive, includes the loss of habitat and community diversity. The plants that are supposed to live there are now being pushed out and they can't grow because of these invasive species. The localized or complete extinction of rare and endangered species, the spread of human pathogens, the choking of waterways, water intakes, and wetland systems. In a drinking water supply, you don't want aquatic invasive species. They can grow on screens, they can clog filtration pipes. They're just not good. And they will cost a city or town a fortune to get rid of these things, or try to get rid of these things once they're in there. So the important thing is to try to not let them get in there in the first place. So an example of the wildlife and water relationship. I know this is brought up a lot of times of how do all of these ecostations interact together. And this is just one example that I like to use. In a healthy ecosystem, we have some standing water, we have mosquitoes, and we have bats that eat the mosquitoes. They kind of keep everything in check. With a projected increase in standing water from climate change, because we're going to have more flooding, and a decrease in bats because they're dying off because who knows, this thing called white nose syndrome and other diseases. What's going to happen is there's going to be more standing water, more mosquitoes, more standing water, and more mosquitoes. The more mosquitoes that we have, there'll be an increase in human diseases like Triple E and West Nile virus. And that's when people start to say, we want the city or town or the state or somebody to kill the mosquitoes. So it leads to an increase in chemicals to kill the mosquitoes, which costs more money, and it can lead to more of a chance of water contamination. And as much as they say these chemicals aren't harmful, they're going to affect the environment. Any chemical that's designed to kill something is going to affect other things. Okay? And how they usually do this, they spray from trucks or the air to kill adult mosquitoes. But the mosquito larvae, which grows in standing water, which a lot of the times is our storm drains, they'll put a chemical, it looks like a hockey puck, down there, and that kills off the mosquito larvae. So you're putting chemicals directly into a storm drain, which is never good. So that's just an example how some of these things are related. Another current issue is the chance of water supply terrorism. It involves intentional sabotage to a water supply system through chemical or biological warfare or infrastructural sabotage. This was an important thing after 9/11 events. We know what happens if there's no water. So if you have somebody intentionally taking away your water source, it is a big event. So some random but important water things. A watershed is the area of land where all of the water that is under it or drains off of it goes into the same place. I like to use the bathtub analogy. If you dump a cup of water on the edge of your bathtub, some of it's going to go into the bathtub and down the drain. Some of it's going to go onto your floor. So that would be your watershed divide. One side's draining to a lowest point on one side, and the other side is draining to the lowest point on the other side. Okay, so we define the boundaries of a watershed by topography. It's going to go from high to low because we know water never goes uphill. This is just an example of a watershed where we have a mountain ridge, and everything that falls on the top of that ridge is going to go to either one side and be in one watershed, or flow down the other side and be in a different watershed. And we all live in a watershed. The largest watershed in the United States is the Continental Divide. One side drains to the Atlantic Ocean eventually, the other side drains to the Pacific Ocean eventually. Some things about wetlands. Wetlands, the most important thing I want you to remember is that wetlands are not always wet. They're wet at some time of the year. Okay. They're identified by plants and hydric soils. So both of those are needed to identify a wetland properly. It's a critical habitat type. It's a historically underappreciated resource. More than 50% of our wetlands are lost nationally. Valued now more than ever for wildlife and plant habitats, for flood control. Wetlands act as a sponge, and they'll soak up pollutants before allowing the water to slowly get back into the system. They use the sediment control. A lot of times you'll see them nice and sandy. And they're also used for recreation. Duck hunters use wetlands, kayaking and canoeing. So they're very important. In Massachusetts, some wetland types are swamps, bogs, marshes, salt marshes, kettle holes, a lot of those found on Cape Cod, lakes, ponds, rivers, streams, and vernal pools. The most important thing I can tell you about vernal pools is that you'll never find a fish population in there because a vernal pool will dry up during the summer. So a little bit about bogs. Bogs are a type of wetland with a depth of at least 16 inches of decomposing moss. Almost all of their water comes from rain and snow, so not a lot of groundwater replenishing these. Water in bogs is low in oxygen. It's an anaerobic system. Very acidic because decomposition happens slowly, and they're often cold. Sphagnum or peat moss is common in bogs. This moss has large cells with openings that absorb a lot of water. This makes bogs very spongy. If you ever stepped on a bog, you could kind of bounce on it, and you'd see the ground moving. Bogs have low levels of oxygen in them because water doesn't flow in and out of them easily. Because it's replenished by rain and snowfall, you're not having a lot coming in and a lot going out. Low levels of oxygen and cold temperatures make it more difficult for fungi and bacteria to decompose dead plants quickly. Bogs are home to rare wildlife and highly specialized plants. Because of their amazing preservation qualities, anything that goes in or happens to fall in a peat bog is usually found not decomposed and intact. And this is why I chose to highlight bogs a little bit. Bogs are my favorite type of wetland. I find them the most interesting. Some things that have been found in bogs are metals, jewelry, wooden items, swords, bodies, and butter. Some of this stuff dates back to 5,000 to 8,000 years. An example, this top picture was a wooden wheel that was discovered in the Netherlands along with another just like it. About 2.5 feet in diameter and carved from a single piece of oak. Been dated to 2700 BC, which makes it one of the oldest wheels found in Europe. And the bottom picture is a 2,000-year-old still edible chunk of butter. I don't know who determined that it was still edible, but it's a still edible chunk of butter unearthed in an Irish bog in 2016. More than 270 barrels of bog butter have been found in Ireland. And if you really like this type of wetland like I do, I wasn't going to put these pictures in this presentation, but Google search bog bodies, and you'll find out how interesting bogs really are. Okay, so before laws existed, you could do anything to wetlands that you wanted to. You could fill them in, you could build on them, you could dredge them. What we have here is a picture of Boston's Back Bay and Fens. And a fen is a type of wetland. So the top picture is from 1882 when they were dredging the Back Bay Fens area. This was taken from a newspaper. And what they did was they were trying to figure out where they could build in Boston. So the way they did that was they dredged wetlands and they built on wetlands and they had a community. So now what's known as Boston's Back Bay and the Fens is the area around Fenway Park. So when you think of Fenway Park from now on, I hope you think wetland. So back before this was built, this was all a wetland. And another interesting note is that Logan Airport is built on a filled-in wetland. So human alteration in wetlands filling. To control that, because they found wetlands are so important in both the ecosystem and to clean water, there had to be a way to not just fill these things in and build on them. So that way was called the Wetlands Protection Act, and that was enacted in 1972. And what it says is that any alteration within 100 feet of a wetland has to have approval to be able to build, fill, alter. Any change of that, cut down trees, has to be approved by a local conservation commission. And every city and town in Massachusetts has a local conservation commission that's in charge of protecting wetlands. There's also a thing called the Rivers Protection Act, which protects within 200 feet of a year-round stream. It's the same process. You have to get approval by the Conservation Commission. And I wouldn't ask you to read the Wetlands Protection Act because it's pages upon pages upon pages of technical and sometimes confusing and sometimes boring wording. But you should know what the Wetlands Protection Act and the Rivers Protection Act were enacted for and their purpose. So besides people, we have non-human wetland alteration. The biggest one are beavers. Beavers can change what's called a lotic environment into a lentic environment. A lotic is flowing water and a lentic is still water. So they take a nice flowing stream, they dam it up, and they make a nice little habitat for themselves in a nice little pond. Okay, and what beavers also do is they create a wetland and they create wildlife habitat. A lot of wet beaver ponds are also blue heron rookeries. If you drive on Route 2 towards the Boston area, there's a huge beaver pond wetland area that's also a big blue heron rookery. You look up and you can see blue heron nests throughout the whole wetland. So they create their own habitats there. The change in water and the water levels causes the water to become hydric, and it also changes the type of trees and vegetation that can now grow, because some plants and trees like wet feet and some don't. And also they change water quality. Beavers, we talked about pet waste. Beavers also have waste, and they're directly in the water. And they change the characteristics of that water area. So eutrophication is the natural aging process of a lake or pond. Lakes or ponds can be oligotrophic, mesotrophic, or eutrophic. And I'm not going to go into this too much, but it is an aging process of a lake or pond. Eventually, way beyond our years, the lakes and ponds that we see now will eventually turn back into wetlands. It's a natural process. It's not a natural process when things that we do affect it and make them older before their time. That's called cultural eutrophication. Excessive plant growth resulting from nutrient enrichment by human activity. These are pictures of actual lakes in Canada. They're called Experimental Lake 227. And they were used by a university in Canada. In 1975, on the top picture, was when they started this study. The bottom picture is that same lake in 1994 after adding phosphorus for 26 years. You can see the difference in the color and what we call their turbidity. And that's just from adding phosphorus, a nutrient. Some sources of phosphorus: stream bank erosion, pastures, croplands, and agricultural sites, urban runoff, non-agricultural rural runoff, faulty septic tanks, municipal and industrial wastewater systems. Because they found that phosphorus was such an impairment to water quality, in 1994, Massachusetts banned it in household cleaning products. In 2008, Massachusetts banned it in dishwasher soap and laundry detergents. And lastly, in 2012, Mass put restrictions on phosphorus in fertilizers, and those regulations became effective in 2015. This is another picture of one of the experimental lakes in Canada. This is number 226. The top of the picture was the addition of carbon and nitrogen. The bottom part of the picture is carbon, nitrogen, and phosphorus. So what we're doing is speeding up the aging process and the eutrophication of these lakes. Okay. The more sediment we add, the older we're making these poor lakes and ponds. So real quick about water quality. Okay. Water quality index, parameters of dissolved oxygen, biochemical oxygen demand, nitrates, turbidity, total solids, phosphorus, coliform bacteria, pH, temperature. Your task is to find out what each of these things mean before a water quality workshop. And each of these are parameters that are used with a different formula that can be found online, that when combined together give one number that supposedly tells us how good our water quality is. Okay. Water quality index is most useful when compared to quality of waters across the world. For example, if we wanted to compare how good the quality of water was in Wachusett Reservoir to a lake or pond in Italy, that number would give us a good way to compare that without comparing each parameter. So how that happens is each parameter has its own formula, which can be found online. There's all added together in another formula, and whatever number you get, there's a range. 90 to 100 is excellent, 70 to 90 is good, 50 to 70 is medium, 25 to 50 is bad, and 0 to 25 is very bad. And from that, it tells what that water would be useful for, whether you could use it for drinking, swimming, boating, fishing, irrigation. The reason why I don't think it's very useful is because you will have one overall number for the quality of your water, but your bacteria levels could be really high, or your pH level could be real acidic. And the water quality index is not going to tell you that because you're just going to have one overall number. So again, it's most useful when comparing it to another water body. So a Secchi disc measures the clarity of a water body with a turbidity of a water body. It's best used in lakes or ponds, and how you use this is you lower it until you can't see the colors anymore. And then you raise it until you can see the differentiation between the black and the white. And you can make one of these Secchi discs on your own using a paint can lid and just some black and white paint and some weights. And this has to go straight down. So you can't use it in a stream or anywhere that isn't really deep. So to combat that, they have things called turbidity tubes, and they can measure the water clarity in a stream. And you'll take a sample, fill the tube up, and then let water out until you can see the black and white colors at the bottom of the turbidity tube. The most important thing I can tell you is when you're looking at water quality samples, you need to remember that that sample is like looking at a snapshot of that sample site at that exact time. When you get sample results, or you're looking at one data set of water quality samples, that's not going to tell you how good, how clean, how dirty that water is just by one number. That's where water quality monitoring comes into play. And you sample that same site over and over and over again, so you have a baseline of what that water quality usually is. Then on the occasion that you collect a sample and you have some number that doesn't look normal, you know that there's something wrong. So that's the benefit of water quality monitoring. But again, the most important thing I can tell you is that when you're looking at one set of water quality sample data, you're looking at that stream at that exact time those samples were collected. In speaking of water quality and water quality data, if you have a public water supply source for your drinking water, you'll get each year what's called the Consumer Confidence Report in the mail. By law, you have to get that once a year, and it will give you water quality data of your drinking water supply. You should take a look at that for your city or town. Compare if you have different water sources than somebody on your team from the other side of town. Look at those water quality data and see if you can tell what the differences are in those, if they're not exactly the same. And if they're different water sources, they shouldn't be exactly the same. If you don't get that in the mail or you can't find it, your water supplier also has to have it, and you can probably find it on the internet. So invertebrate indicators. Aquatic invertebrates live in the bottom parts of our waters. They're also called benthic macroinvertebrates, or benthos. What that means is benthic is bottom, macro is large, we can see it with our eyes, invertebrate, animal without a backbone. They make good indicators of watershed health because they live in the water for all or most of their life. They stay in areas suitable for their survival, are easy to collect, differ in their tolerance to a mountain types of pollution, are easy to identify in a laboratory, often live for more than 1 year, have limited mobility at integrators of environmental condition. Macroinvertebrates are pollution tolerant, pollution intolerant, or somewhere in between. So basically, we use bugs, and again, this is like the water quality data. You can't collect bugs once and determine how healthy that stream or lake is. You have to collect bugs in the same area over time and see the changes to determine how clean or dirty that water is. And some of these invertebrates like leeches. We've all heard of leeches. They live in dirty water. So they can tolerate a lot of pollution. So they would be a pollution tolerant. A caddisfly, on the other hand, those little bugs that make their own little houses, are pollution intolerant. You find those in clean water. So there's a formula that, again, you can find online if you Google macroinvertebrate monitoring. There's a formula depending on how many of these macroinvertebrates you find in one area will tell you the quality of water in that area. What protects our water? The overall arching law that protects all of the waters in the United States is the Clean Water Act, or Federal Water Pollution Control Act of 1972. The act established the goals of eliminating releases to water of high amounts of toxic substances, eliminating additional water pollution by 1985, and ensuring that surface waters would meet standards necessary for human sport and recreation by 1983. Not all of our waters meet those standards, and it's 2020. Safe Drinking Water Act also protects our waters. This was 1974. This was originally passed by Congress in 1974 to protect public health by regulating the nation's public drinking water supplies. Law was amended in 1986 and then again in 1996. Requires many actions to protect drinking water and its sources: rivers, lakes, reservoirs, springs, and groundwater wells. Safe Drinking Water Act does not regulate private wells, which serve less than 25 individuals. And the Safe Drinking Water Act authorizes the U.S. EPA to set national health-based standards for drinking water. So although this is a national act in Massachusetts, the Safe Drinking Water Act is administered by the Mass DEP, Department of Environmental Protection. And there are different regulations that drinking water suppliers have to meet to be able to deliver tap water to your house that's safe. So tips for any research. This is especially important this year when we're talking about climate change. Use reliable sources. Internet sources ending in edu, gov, and even org and journals are usually pretty good. Org should be, you should check a second source and make sure that information is correct, because that's usually an organization. Material and information from sites ending in .com may or may not be biased and should be verified with other sources. So check in more than one place if you're using something from a .com website. And just as an example, the picture on the left is from Vogue magazine, How Clean Is Your Water? I don't know how much I would trust Vogue magazine to tell me if my water is safe or not. So that's just an example. So some topics to focus on: thermal pollution, the pharmaceutical circle and the concept of the pharmaceutical circle, stormwater pollution, climate change, global warming, wetlands, eutrophication, the water quality index, and the water quality parameters. Know how the water quality parameters are related. That's probably the most important thing that I would want you to learn about water quality parameters. Know what they are and know how they're related. Macroinvertebrates concept, laws that protect our waters, just a general overview of what they are and what they protect. Don't go reading through the whole Wetlands Protection Act because you'll get pretty bored, but know what they are and what they're for. And groundwater movement and groundwater pollution. You can find more information in this presentation on the Mass Envirothon website, which is massenvirothon.org. And you can use those in your research, even though it is an org site. They have been verified a few times. The water page has a lot of resources for you to use. Also, you can contact your local watershed association if you want to help collect water quality samples. They're always looking for volunteers. They have a lot of information on your watershed that would be very helpful in your research. Find out where your water comes from. If you don't know what your water source is, please find out what it is and how you can protect it. We're all responsible for protecting our own waters and everybody else's waters downstream. So that is something you can do. And I just wanted to thank everybody for attending our first webinar tonight on Imagine a World Without Water Day. And thank you.